Okay, guys, we're going to take a look at modeling with graphs. So this is a big part of the course, and let me make sure I got my pen going on here. We'll go with this purple again. Yep, we're good. First part here, we're just going to go over the basics of graphing. So you guys have done a lot of graphing in the past. I think if not, we'll just go over this real quick. This is called an ordered pair. So whenever you have two brackets like this, round brackets with a comma and then numbers in between, so like 5 and 6, that's an ordered pair, and we only graph in 2 dimensions. So we have side to side and up and down dimensions. That's all you do in high school and most of university, actually. You might graph in 3 dimensions one day, but that's different. Maybe 4. No, I'm just kidding. 3. So when you plot points, what you're going to do is you're going to move side to side and then up and down. So the point A is the point 2, 4, which means I'm going side to side 2 and up and down 4. When we go side to side, this guy here, over here, so you got the y, the x across and the y-axis like this. So this is your x-axis, this is your y-axis. Everything on the right of the origin, which is 0, 0, right here, is positive, and everything on the left is negative. Everything above is positive in the y direction, everything below is negative. So the point 2, 4 means go right 2, 1, 2, go up 4, 1, 2, 3, 4. And then you can look at certain other points like this. C says go side to side -3 and up and down 5. So you go left 3, up 5, and that would be the point C. Okay, so that's the overall of that. If you're going to connect points to make a line or a line segment, in this case, what you'll do is you just take a ruler, which I didn't do, but take a ruler and then connect the points. So if I wanted to connect C to A, I would go like that with a ruler and connect those to get the line segment CA or AC. It doesn't really matter the order that you put it in. We'll do lots about lines, so you get used to it. First part of this, we're going to talk about partial and direct variation. What's the difference? How can we tell which one's which? And then we're going to get into slope. So that'll be the extent of this video. And then we'll move on to more and more about slope until you know so much about slope, it'll be crazy. Okay? So basically in class, we probably went over this already. We look at the ways to talk about a relationship. A relation. And this is, you can do it in words, you can do it with a table of values. So this will be your, when you plot anything, this will be your independent variable and then your dependent variable. So when you have a table of values, you have independent and dependent. And in general, that's x and that's y. Not in general, it's always x and y. Okay? So this column here will be our x column, this column here will be our y column. Sometimes we don't call it x and y. Like in this case here, you might call it distance here. So distance would go this way and cost would go here. So, but regardless, this is your independent and this is your dependent. Okay, so something happens and it affects something else. Okay, so you do something, you travel a distance and you decide how far you're going to travel. That's independent, and then the cost goes up. Okay, you might have another one where you look at hours worked and then money received or something like that, or money earned, sorry, paid. So you decide, or someone decides how much you work, and then you get money. It doesn't work the other way around. They don't go, here's 50 bucks, and that automatically makes you work 3 hours. Okay, maybe you work 3 hours to get 50 bucks, but it doesn't work the other way around. Okay, so that is a table of values, independent, dependent. You can also have an equation. When you have the equation, you're going to have your dependent here. So most of the time, we're going to have y equals blah, 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 x over here. This, so again, we get to your work. Okay, so the number that, the amount of money that you make might be something times the hours that you work. So over here, you're going to have something times hours worked to get the amount of money that you have. Okay, so this is your independent. And then you graph them, and when you graph them again, this is your independent, this is your dependent, this way. So here's a situation. We have milk plans in a cafeteria. So let's say you go to school and you want to buy milk. There's 2 options. One, you can get $2. You pay $2 every time you get milk. So there's not really a plan. You just walk in there and you pay $2 for a glass of milk or a thing of milk. It says glass, so we'll go with glass. Plan B, so that's plan A. Plan B says you pay $3 up front and then you only pay $1 per glass of milk. Okay, so in your head you might start thinking, oh, I drink a lot of milk. This might be a better deal. Oh, I never drink milk. This might be a better deal. Or which one's a better deal or whatever. Okay, or you say, I'm not going to commit to something. Maybe I'll choose the one where plan A, where I just drink as much as I feel like or whatever. Anyway, we'll make a little table of values, and to do that, we're saying if you drink 0 glasses, you're going to have $0 in plan A, okay, because it's $2 per glass of milk. If you drink 1 glass, you're going to pay $2. If you drink 2 glasses, it'll be 2 plus 2. Or another way to do it is there's $2 per glass. You're going to multiply that by 2, or even better, 2 times $2. This will be 3 times $2. Okay, so again, I'm using the dot here, but 3 times $2, you can write it like that for multiply. And you get $6. 4 glasses of milk will cost you $8, and 5 will cost you 10. Okay, nothing special there. We can look at the other situation where if you don't, plan B here, where you don't pay anything up front. So, sorry, that's wrong. You pay $3 up front. So if you don't drink any milk, you pay $3 off the bat. But if you drink 1 glass, you're going to pay 3 plus 1. 2 glasses will be 3 plus 2 times 1, right? 3 plus 1 plus 1 plus 1. Or another way to write that is 3 plus 3 times 1. Okay, so I'm kind of leading us to where we're going eventually with this. 3 plus 4, etc., etc., etc. Okay, so those are your numbers. When you graph these guys, what you notice here in A is A and B are graphed, and then a couple things here. The first thing we're going to graph, and this is important when we talk about is direct or partial variation, is that this guy goes through the origin. So it starts at 0, 0. If it starts at 0, 0, I'm going to give you the heads up here. This is called direct variation. Partial variation varies partially due to the independent variable. Okay, so what happens here is it's already has a fixed cost here. Okay, it already is $3. And then it changes as time goes on, okay? This guy starts at nothing, and it only changes depending on how much you use it, okay? So direct changes completely by the independent variable. Partial has some sort of value that isn't 0 to start with, and then changes because of the independent variable. So they both change because of the independent variable, but one has a value of 0 when there is no independent variable, okay? So when you have 0 glasses of milk in part A, you have $0 spent. In this one here, in partial variation, you started at $3 and then you move up after that. Okay. So how do they differ? The slope and the start point. The slope doesn't matter. So we're talking about the steepness here. The steepness, it's not as though one partial variation is steeper than direct variation or vice versa. Okay. These two do differ. Okay. This guy is steeper than this guy. Okay. There's no doubt about that. But the key here is where do they start? This starts at 0 and that starts not at 0. So direct variation is a relationship between two variables in which one variable is a constant multiple of the other. So I said the dependent, but it's the dependent variable is the constant variation of the other. And when you have a table, you're going to have 0, 0 in your table. So 0, 0 will be in your table. You're going to have an equation that just looks like this, y equals something. Okay, and how that's different in partial variation is you won't have 0, 0 in your table. And you're going to have something like k something times x plus 2. So we look over here when we went through these were just 3 times 2, 4 times 2, 5 times 2. These were 3 plus something. 3 plus 3 times 2. You get the plus, okay? And the plus, it means that this guy here is your starting point, okay? So you're starting at $3 no matter what. You start at $3, $3, $3. That is going to be, this is a Pizza Hut commercial. That's going to be partial variation. Okay, the graphs goes through the origin, doesn't go through the origin. Okay, partial versus direct. Other way around, direct versus partial. Hope I didn't mess any of those up. Sometimes I get excited. Direct is this guy, 0, 0. Equation just starts with no plus, okay, or plus 0. You can think of it that way. Graphs go through the origin. Partial, you have a multiple with a constant. You don't have 0, 0 at the origin. You add something here, and you don't go through the origin. Okay, you do not start down in the corner, you start somewhere up here. Okay, and let's get to slope. Okay, so in slope, slope is the steepness of a line. So we kind of already mentioned that earlier. You guys would know that. Here's the slope of a hill or whatever. Okay, when we read left to right. So we talk about a line being having any sort of slope. We're reading this way. Okay, don't read backwards. Don't read right to left. We always read left to right like we read English words. If it's going up left to right, so if it's going this way, it's increasing. Okay, it has a positive slope. If it goes this way, then it's decreasing. So from left to right, this is going down, this is going up. Don't get confused and say, this guy's going down this way. We don't look at it that way. We just look left to right, this guy's going up. So you start over here, basically you start over here and you're going this way, and then you say, is your line going up? Is it positive, or is your line going down? Is it negative? Lots of ways to get slope. The first way we're going to do, first thing we're going to do is look at the rise and the run. So what you do is, first of all, we just want to see these points, these slopes here, and talk about if they're positive or negative. This guy's going down, so it's going to be negative. Okay, it's a negative slope. This guy here is going up. It's positive, negative, positive. Rise and run is one way to look at slope. And what you do is you take 2 points and you ask yourself, does it go up or does it go down, and how much does it go up or down as it goes over? So how much does it rise? Okay, and rise, we also talk about, like, rise goes with fall. Okay, so rise would be positive, it's going up, and if it rises negatively, then it's going down. Okay, and then we're always running in the positive direction. We always run this way. You could do a rise or a run question where you're going backwards like this. I don't recommend it, because all your signs are going to be backwards. It turns out to be the same thing, but you have a positive where you have a negative, and a negative where you have a positive. That sounds confusing? It is, so don't bother. Okay, so what you do is you start at A, and you say, if I go from A to B, how much do I go up or how much do I go down? I'm going from A to B, so I go down 1, so that's your -1. While I go over 1, 2, 3, 4, 5, that's my run. Okay, so I have my rise and my run. I went down 1, and as I went over, down 1 as I went over 5. Okay, so that's a little confusing. Down 1 over 5. This could be positive or negative depending on if it goes up or down. This is always positive. This is a negative, so the whole thing becomes -1/5. When you write this out, do you write it like this or do you write it like that? They're the same thing, okay? In general, we like the negative in front, but there's nothing wrong with the negative being on top. We never write it like this, though. Don't write this, please. We don't put the negative on the bottom, okay? No good. So you look at another one. I'll jump to EF. What's going on here? I'm going from here to here. I'm going up, and I count 8. And then I go over 2. I went up 8, so that's +8. You don't need to put the positive, but you could. And that's over 2. You write this in lowest terms. You always write this in lowest terms. 8 over 2 is 4. Okay, so if it's a fraction, so let's say, for instance, let's say it was 5 over 15. You would write that in lowest terms as 1/3. Okay, so that's important to do that. If it's a number like this and you can get a whole number out of it, it's even better. Okay. So the bigger, now if we're going to compare rises and runs, let's look at C, D, and E, F. They're both positive, so they both have the same sign, okay, that they're positive, but this guy's steeper than this guy, so EF is steeper than CD, and if we do the math here, we find out that EF has a bigger slope than CD, okay? Not surprising, okay? The steeper has a bigger slope, right? You would say that if you're on a mountain, you go, that's steeper, it has a bigger slope, for sure. A couple special cases. This guy here has a rise of nothing when it has a run. So a guy that goes horizontal has a rise of nothing. I'm sure I used this example in class. I think of a roof, okay? And if I had a roof that was flat, if you had a roof, that's a pi sign, but if you had a roof that was flat and you said, how steep is that? You would say that has a steepness of 0. You can also have a line that goes up and down. So if your roof looked like this and you go, that's not a roof. No, it's not a roof. Okay, it's undefined. If you have a rise that is 10 and a slope that is 0, if someone builds you this roof, that's not good, okay? So if you have a rise of something over a run of nothing, because you're not moving, okay, side to side, you're going to have something that is undefined, so this has an undefined slope. And then you can just go through here, look at different ways to look at this, rise and run, find this sort of thing, etc. Okay, so get 2 points, get the rise, get the run. There you go. Steep positive goes this way, it goes up. Negative goes down. Bigger positive, okay, and this would be a bigger negative. So let me just go over that real quick. Bigger negative. What a bigger negative is a bigger number that is negative. Okay, so for example, this guy here, GH versus AB, there are 2 negative lines here. Okay, and you would say this guy's definitely more steep than this guy. And if you look here, this guy has a slope of -2, and this guy has a slope of -1/5. So this one here has a bigger negative number. Okay, so it's more negative. So the number, the magnitude of the number, determines the steepness. Okay, this determines if it goes up or down, positive up, negative down. And this guy here, the size of the number, is, regardless of sign, the bigger is the steeper. Okay, that's it.